Hello. This is Zoe from Seneca, and today we're going to be looking at covalent Lewis structures because there's more Lewis goodness to go around. So, Lewis diagrams can be used to represent covalent bonds and to show the sharing of electron pairs. So, for chlorine, each chlorine atom begins with 7 electrons in its outer shell. So close yet so far. By sharing one pair of electrons in a single covalent bond, each Cl atom obtains a full outer shell with 8 electrons. That's what we like. Okay, now for water. Because oxygen has 6 electrons in its outer shell, it needs to have 2 extra electrons shared with it to get a full outer electron shell. To do this, it forms a single covalent bond with 2 hydrogen atoms. Double and triple bonds. The earlier examples show single covalent bonds, which is just one shared pair of electrons between atoms. But also, it is possible to form double with 2 shared pairs, or even triple. Hold on there, seriously? Yeah, triple covalent bonds with 3 shared pairs. Double and triple bonds are normally stronger and require more energy to break. Each oxygen needs 2 electrons to get a full outer shell. Therefore, each oxygen atom shares 2 electrons with the other, leaving 2 pairs of electrons in the shared space between the atoms. This is an example of a double covalent bond. So, a single covalent bond has 1 shared pair of electrons between 2 non-metal atoms. A double covalent bond has 2 shared pairs of electrons between 2 non-metal atoms. And a triple covalent bond has 3 shared pairs of electrons between 2 non-metal atoms. Okay, each hydrogen atom needs to get 1 extra electron to get a full outer electron shell, right? So, each hydrogen atom shares 1 electron with the other, leaving 1 pair of electrons in the shared space between the atoms. This is a single covalent bond. When carbon reacts with hydrogen to form methane, how many hydrogen atoms will bond with each carbon atom? And the answer is 4. Each hydrogen atom needs 1 extra electron shared with it to obtain a full outer electron shell. Each hydrogen atom forms a single covalent bond with the carbon by sharing 1 pair of electrons. The carbon needs 4 extra electrons shared with it to obtain a full outer electron shell. So the carbon forms single covalent bonds with 4 different hydrogen atoms. There are many ways of representing covalent bonds in a molecule. 4 ways of representing ammonia is showed below on our website. So, a line diagram, the atomic symbol represents the atom. Lines between the atoms represent a covalent bond. A dot and cross diagram without shells. So dots represent the outer electrons of atoms of one element, and the crosses represent the outer shell electrons of atoms of the other element. Dot and cross with shells. It's a bit clearer this one actually. So dots represent the outer shell electrons of atoms of one element, and the crosses once again represent the outer shells of atoms of the other element. But a limitation of this method is that it only shows electrons differently for each atom, when they're actually the same. So, ball and stick diagram. In this, the balls represent atoms, and the sticks represent bonds between the atoms. A limitation of this method is that the atoms are much closer together than the diagram shows. I'll give a bit of space, but they're actually super tight. Okay, so which of the following is not a way of representing covalent bonds? Dot and cross, yes. Ball and stick, yes. Line diagrams, yes. So pyramid diagrams is the incorrect answer. When compared with single covalent bonds, double and triple covalent bonds, A, require more energy to break, and B, they're stronger. Okay, that's all for today. Thanks so much for joining, and we'll see you next time. Can't wait.